I love that this is the stuff sucks room today, in which earlier we saw how Scrum sucked, and earlier how CSS sucked, and now JavaScript, we all suck at that too. It's an absolute nightmare. I'm very sorry. Hopefully we'll get through feeling less sucky by the end. In fact, if it turns out that you don't do any of these issues, you're going to feel great. Let's get started. My name's Nash. I'm a developer advocate for Sonar. Sonar is a place that does static analysis for your code. We help you write clean code. We have like 3 products which you might have heard over the name Sonar. Sonar Cube, Sonar Cloud, servers for analyzing your code as part of your pipeline, and SonarLint sits in your editor as a linter to analyze your code as you write it and help you write cleaner code. That's sort of what we will apply that a bit later as part of the talk as well. But then myself, that's me. I'm Phil Nash all over the internet on as many social media platforms that allow you to write 140 or more characters these days. I'm not going to call it X. Go find me on Mastodon instead, or Blue Sky, or Threads, or Pebble, or yeah, there's loads of it. Too many. It'd be absolutely great to connect with you, and I'm always happy to answer questions now, rest of the day, or online later. Please get in touch. So, top 5 issues in all of our code bases. I want to start by telling you where I got the data for this, because that's sort of important when I'm saying that these are the issues in our code bases. That's implying that you are also writing issues. I'm sorry, I don't mean to, but you are, because these exist. So what I did actually was look into Sonar Cloud. Sonar Cloud is a SaaS solution for scanning and analyzing your code base. And of course, so it comes up with issues that can be found via static analysis. And I went to the Sonar Cloud team earlier this year and I said, hello, can you run me a query and get me like the ones that we see everywhere, the top, I actually asked for the top 10 at the time just to see what I could find. And we have the time for 5 today. I said, give me the top 5, the most common issues that we could find in any of these code bases. And that's what I got. And of course, so these issues are issues like I can't tell if you've written a business logic bug in your code. That's possibly the greatest issue we have entirely. What we can tell is issues that can be found through static analysis, through looking at code and not running it, but observing how it might work. And so that's where this data comes from, these JavaScript issues that I'm kind of talking about. And ultimately, it gets to that idea of writing clean code that is sort of ultimately maintainable, but also reliable and secure and accessible, and all the things you want your applications to end up being. We have this idea that if you write clean code, then the outcome is a great platform, it's a great application, but also something you're happy to come back and work on again. Code that is maintainable in the long run, because code is read more often than it's written. Certainly in my case. Indeed, I ended up looking up a couple of quotes about this kind of thing, and this is one of my favorites, all the way back from 1991, saying, always code as if a guy who ends up maintaining your code will be a violent psychopath who knows where you live. Code for readability. That was on a C++ mailing list by, I think, games programmer called John F. Woods. I like this one because it does at least make you consider other people. It was 1991, which I guess is why he wrote guy instead of person or whatever, but if you consider the person in the future who has to deal with your code, then you might be nicer at it. And I actually looked further into where this quote came from because it was part of a thread in this mailing list. And it's wonderful how sort of so many quotes, I think, actually live on from mailing lists of years gone by. But this thread initially was actually about the comma operator in C++. And people arguing whether this was a cleaner pattern. If you use the comma operator, you can do more than one thing on a line of code. In this case, assigning 2 different variables. And I thought this was interesting because actually this also parses as JavaScript as well as C++. Not that we should ever write code that necessarily does both of those things. But the argument was this is cleaner because we don't have to have braces around our conditional thing now. We've got it all on one line and we don't have to worry about extra lines of code. That might have been an important thing for C++ developers at the time. But it was argued against, actually, ultimately. The point in this case being that the comma is a very small operator. It's very hard to see, and it's very hard to see if you've made a mistake with it. And indeed, if you typo that for a semicolon, which is possible, they're not too far away from each other, and the semicolon has a comma in it, it's quite hard to spot. Now, obviously, my syntax highlighting has made that more easy to spot on this slide. But in 1991, everyone was presumably just typing in green and black screens, and you don't get the opportunity to see that kind of thing. And so, and if you're a JavaScript developer, you've probably spent some of your time in your career hunting for a semicolon that's either in the wrong place or not in place at all in order to get something right. And so it was argued that actually it is not a clean, it's not a good way to code to use comma operators just to remove braces from conditionals. Terrible idea overall. I like that. And then I found this other quote, which I also quite liked. We talked about in the previous one, coding for readability. And in this place, Raymond Chen on the old new thing, Microsoft blog, said design for readability. Even if you don't intend anybody else to read your code, there's still a very good chance that somebody will have to stare at your code and figure out what it does. And that person is probably going to be you 12 months from now. If you add these two together, you've got to watch out if you yourself happen to be a violent psychopath, because you definitely already know where you live. But I really like this idea, designing for readability and coding for readability because of future people having to deal with stuff. If we write our code with the consideration of the person in the future, especially if that person's you, then you're going to have a better time when it comes to that future. And so that's sort of our idea of clean code. Ultimately, like it runs better in production if you write code with fewer bugs in it. If you write maintainable and easy to read code, you'll write code with fewer bugs in it. You'll write code with fewer issues in it. And then you'll actually be happier to go back and work on it again because it'll be easy to read and understand the next time, and the next time. And so that's kind of what I'm pushing for here. So what are these top 5 issues? Well, I have a top 5, and it's quite funny. When you find the most common issues, it turns out they're not particularly surprising because they're very common. They're everywhere. So I will be counting down the top 5. I'll be doing so in reverse order. And in order to add to the excitement, I also added confetti. So hopefully that's okay. We will start at the bottom. I'm not even going to do these in order, but we will start at the bottom at number 5. Number 5, 5 issues in JavaScript projects that I found on Sonar Cloud was, not bad. So we're streaming this through Zoom. So now that's a Zoom lag on the confetti there. Unused assignments. It turns out there's quite a lot of code knocking around in people's applications where variables are assigned to something and then reassigned to something again later. So in this case, this is just made up code, an example, but the idea of assigning to something and then assigning to another thing and not using it in the meantime, meaning that that first line is just useless. It's pointless. And that's a shame. Now, things don't normally necessarily happen like this, but this is just sort of clutter. This is code that doesn't need to exist. It's actually stuff that the function doesn't have to do. So it's a performance issue, potentially, doing things you didn't need to do. But really a readability issue. If you're there trying to understand why the first line in this example is there, and then you find out it was never used, you've spent that time, worked up a bunch of things in your head, and now you don't know, and you have to throw them away because it happens again. Although this did turn up, and I found this in a bunch of open source projects as another kind of thing. In this, which looked a bit like this, we had a function that returned the assignment to a variable that was outside of the scope. And so in this case, the function is doing something, but it's also setting the state of a variable that's outside of the scope of the function itself. I think this is a really ugly pattern. I'm a fan of the idea of pure functions, particularly in the case where you can have a function that when you give it to a bunch of arguments, it will do the same thing each time and not affect anything outside of it. That way, you know what that function is going to do. But in this case, we're not. We are setting a state somewhere else in the application, and this came up surprisingly often. And I don't like it. So if you ever find yourself like setting a state and returning a result, we don't need that. Just use the result of the function wherever that extra state is being set. You don't know what you might be changing somewhere else. It's a weird pattern, but I wouldn't talk about it if I hadn't found it in a surprising number of places. So unused assignments, don't like them at all. Number 4. Who's a fan of using the double equals operator for checking equality? Nobody, good. I've had people put their hands up and they're like, I love double equals. It's a, right. it's always fun finding out what double equals actually does come up true with, isn't it? A wonderful person put together this diagram showing all the things that double equals returns true at. The green squares are where the answer is true when you compare the two things on the X and Y axes. And so down the central line here, you can see like things that are actually the same because they are comparing against each other. Of course, we get to the bottom here where we have things that look the same but aren't, like empty objects, empty arrays, and not a number is not equal to not a number. Sure, we know that, but we also don't necessarily have to know that an array with a single item in it that's a number 1 is double equal to true. And also to 1, apparently. It's just an interesting throw a dart at a dartboard with a blindfold on, and you get true or false depending on what you throw in. And so I did find some people being like, yeah, I love this. After asking them a bit further about that, they kind of mostly went, actually, I like it for checking if something's null or undefined at the same time, because double equals, where are null and undefined? They're here. And so that's the null and undefined green square in the middle there. So if you use double equals and it's null or undefined, it will be true or false or whatever it is. I don't know, I'm confused. But I always think that it's much easier to be clear about things. If you want to find out if something is null or undefined, you find out if something is null, and you find out if it's undefined, and you OR that. That's fine. That's much easier, I might say, because this is the same graph for triple equals, right? It's only when the things are the same, and then we realize that these things at the bottom are not the same because they're new objects. They're not. They're equivalent. They have similar things in them, but they are not the same object. And so we don't have to worry about that anymore. Triple equals is a much happier place to live. So we all agree with that already, so I don't have to bang on about it too much. Triple equals is much better than double equals, but it is the 4th biggest thing that turns up in JavaScript projects. When we analyze that kind of thing anyway. In number 3, sections of code being commented out. And this is another one for just readability, I think. I didn't even have an example for this, just a title side, because it's simply the idea of having code that's in a function or in a file somewhere, and it is commented out. Because my problem with that, if I ever come across that, is I'm reading through a function, and then I hit some comments, which also have some code in, and then I read through those comments with the code, and I'm trying to work out what that code does, but it doesn't matter because it's commented. This is useless brain cycles for me here. And then I get to the bottom of that, and I'm like, okay, to pop all of that stuff off the brain stack and go back to the bit that was before. It's clutter. It gets in the way. Commented out code that is, when we're talking about this, we're talking about like checked in code here. This is committed, pushed to a branch and scanned by an online service. So this is stuff that's been checked in. I can see why you'd comment things out as you're playing with things or trying to fix a bug. But if you find something that's been checked in that's commented out, I'm guessing that exists for sort of history reasons. You want to know what it used to do, perhaps, as context of some sort. But that's what we have version control software for, right? That's what Git should be doing. Like, as long as you've committed code to a repository, you don't need to comment it out afterwards. You can delete it, but it's still there. Right? We can always go back and find it, and that's nice to know. It's safe to think about that. And so commented out code turns up the 3rd most number of times in Sonar Cloud repositories, at least JavaScript ones. And that just kind of surprised me. So we got through 3 of them out of our top 5 in JavaScript. And I thought I'd actually take a little swing and look at TypeScript as well, because I can do that. TypeScript is deemed a different language under Sonar Cloud, although they actually mostly use the same processing underneath, which is it's kind of interesting. We can tell a little bit more about TypeScript because of its types, but funnily enough, the TypeScript checkers can tell quite a lot about JavaScript as well. So this is I also found the top 5 of JavaScript, and I thought it was a good time to take a break because actually number 2 was commented out code in TypeScript. TypeScript developers much happier leaving code commented out in a place than JavaScript, only by one place, I guess. So I'll run through these ones quickly because I've got more to say about our top 2 in JavaScript, which we'll get to. But in number 5 in TypeScript, was tracking users of to-do tags. To-do tags being back to code comments again, actually, funnily enough. But in this case, comments that actually, have a thing you need to come back to. Do you use to-do tags in your things? I'll get some nods there. Yeah. So it's not necessarily an issue. It's certainly not a bug. All it means is something you haven't done yet, which is fine. Although it is important, and when using a tool analysis tool like Sonar Cloud to keep an eye on like your project's health over time, if your list of to-do tags is just ever increasing, then that might actually be some sort of other problem. It's not a bug, but you might want to address it still. Not necessarily an issue. Just don't let them build up. That's fine. Just do them, not to do them. It's very easy for me to say, just do your jobs. But I know you've got priorities and things to go through. But as I say, if over time we're just ever increasing to dos, then that's more of a worry. Number 4 was a React issue in TypeScript, which is actually very nice to see in terms of people using TypeScript for React projects. And this one was just using you don't bind things within JSX, basically. The idea that every time you re-render this component, you are rebinding a function is a potential issue for performance in your application. This is funny. So this is all it's actually been dropped out of the latest React documentation, but old React documentation used to say this is probably not a problem for you, and when it becomes a problem, you can deal with it then. I don't like that idea personally. If we can see problems, I'm not one for over-optimizing up front, but if you can see problems that might happen in the future, which are relatively easily handled, I'm much more in favor of handling them at that point. The way to, of course, handle binding inside of JSX is to bind it beforehand. In this case, in a class-based component, you would do so in the constructor. In a functional component, which honestly I should have done this example with, you would do with use callback or use memo or something like that. Bind them beforehand. Don't make it do it every single time it re-renders the function, even if it's not a problem when you first write it. I hate coming back to problems that you have to search an entire code base for to find like every way you might be doing something. So that's that one. And then number 1 in TypeScript was unnecessary imports, which is, I kind of find this quite surprising that importing something and they're not using it. It's the biggest problem. It doesn't cause a problem, of course. It's again more clutter. There's so much clutter in this top 5, and this is what I said. These issues are not necessarily things that are going to drop your application to its knees, but it is cruft that builds up over time. I'm sort of surprised by this because I know that my IDE highlights things if they're not being used. I know that TypeScript will highlight a thing if it's not being used, but actually, because we're in TypeScript world here, when it doesn't actually cause any problem with the runtime of the application, because TypeScript will strip out an unused import as well. So it's not going to fail your build, it's going to strip it out. But this is all about, again, coding and designing for readability and yourself in the future. If you come to the top of a file and see a bunch of imports and then find out that half of them aren't used, you probably have some questions. You probably find some of them are used just in those commented out bits of code later, according to the number of issues anyway. So it's just something to be aware of. If you find you've got unnecessary imports in a file, get rid of them. It's brilliant. It's easy. It can cost you nothing. So let's go back to JavaScript. We've got 2 more on our top 5 for JavaScript. I'm going to hit number 1 first. It gets a little bit more confetti for being number 1. And before I do, any guesses as to what the biggest issue that static analysis can find in JavaScript projects?
Maybe something related to async await.
Async await. Oh, that's an interesting one. I don't think it's popular enough for that to be that big of a problem yet. It's a good one. Misuse of promises is one that I keep coming up across in my own code, which is annoying. No, our top one in JavaScript is using var instead of constant let. Now, constant let did enter the language back in ES5, right, which was 2015. So it's only 8 years ago they've been knocking around. Now, we could, of course, be talking about some legacy projects here, projects that are maybe not changing a lot, causing this kind of thing. But I still think it's interesting to consider. Of course, var and let and const, again, it's not something that's necessarily going to cause your application enormous amounts of problem. It comes back again, I think, to communication, because const and let communicate just more intent around using of a variable than var itself does. Var says we're using this, we can change it whenever, we're hoisted to the top of the function, and we're in scope for almost everything. Whereas const and let, const says that within this block scope that I'm in right now, we are not going to reassign this variable, and let says we can. And that is just a bit more communication. It tells you that little bit more nuggets. And when I like to think about code as a bit of a story that we're trying to tell both ourselves and the computer at the same time. And the more communication, the more meaning that we can put into every part of that story, the better it is to read later and understand. Now, before I go on and before I hit number 2, which is my favorite, I do want to say that I'm in no way suggesting that everybody kind of drops everything on Monday and says we need to do a sprint based on changing var to let or const, depending on where we are in the code base. That's a terrible idea, because presumably your code is running fine right now, even with vars, and if you have that, or with double equals instead of triple equals, things like that, or with these unused assignments, like it's stuff that doesn't matter. But what I am saying is, if you come across these in your code base as you are working through your daily routine, as you're working through features or bug fixes, then it's ideal to keep these kind of things in mind and just kind of just tidy them up, just refactor them as you go. Just as you find that happening in a file, just do a little refactor before you start the work on the actual function or the actual bug that you're dealing with. And that way, your code is going to, improve just slightly. And these are just 5. Like in Sonar, we have about 350 rules that we can apply to JavaScript and to TypeScript, and sort of like, generally suggest getting a linter or something in your editor. SonarLint, for example, is free, although ESLint is doing the same kind of job as well. Get those, have them in your editor, and when you see those little errors, see those little warnings pop up, just deal with them as you're dealing with stuff. Especially when they're small ones, especially when it's something like commented out code, it can just be removed. It's a delight. And then there's number 2. Number 2 is probably less likely to cause you no trouble to change up. Number 2 is the cognitive complexity of our functions. It's too high. Lots of confetti for this one. I like it. Possibly too much confetti for this time. Cognitive complexity of functions is too high. It turns out it's number 3 in TypeScript as well. More confetti. The cognitive complexity of functions is too high. It goes into the next page. Has anybody heard the term of cognitive complexity before? Yes. A few people. Cool. Right. Confetti's done. It's good. Have you heard the term cyclomatic complexity before? That's same hands. Okay. Cyclomatic complexity is older than cognitive complexity, which is why I kind of assume that it might have been heard a little bit more. The cyclomatic complexity is a score for a function or a piece of code. Basically tells you how many different ways there are to pass through that piece of code. Cyclomatic complexity, takes those branches, those loops, and that kind of thing, and adds them up into this kind of single number that you can use to appraise a function and tell you how complex it is. But cyclomatic complexity sort of has some issues in that, because it is generally just that description of how many paths, how many tests you need to write effectively to cover this function entirely, it can skew kind of results as well. So here's an example of counting cyclomatic complexity in a function called sum of primes, which sums prime numbers below a max number that we put into the function. And so cyclomatic complexity is great because it scores you 1 immediately for being a function, because you have to, if you have any function, it takes 1 to test it once, at least. Then it scores 1 for a loop. It scores another 1 for the second loop. Then we've got a conditional here, which scores 1, and then another conditional that's outside the inside loop, and that scores 1, giving this function, relatively complex, 2 looped, 2 conditional set of prime number summing, a score of 5. And then there's this function, which tells you a word to use when you give it a number, like 1, a couple, a few, many, or lots. And because there are also 5 ways to get through this function, 4 ways and it's already a function, it also scores 5. But we'd probably agree that even though you would have to write 5 tests to cover this entirely, it's still less complicated, less complex than this summing of prime numbers. And so cognitive complexity is a score in a similar way that was intended to better score functions for the idea of that readability and ultimate maintainability of things. So psychomatic complexity, as I said, measures the number of paths through a function, and cognitive complexity itself effectively measures how easy it is to read a function. Now, it does this with similar rules, but rules that are tweaked for that idea of readability over just like number of paths. So cognitive complexity creates you a score for a function by adding 1 for breaks and flow, things like loops and conditionals, very much the same as psychomatic complexity, but different. It increments a nesting score. It actually has this background nesting score that starts at 0, but as you nest in either a conditional or a loop, it kind of adds 1, 2 in the background. And then every time we hit this break and flow, we don't just score +1 for the break and flow, we score +1 plus the nesting score. And that way, I mean, it's obviously, it very much dislikes nesting. But if we applied this to our sum of primes function, and we don't score to be a function in the first place, that's having everything start at 1 is not that much use. But then we hit this first loop. We've got this for loop here, and we score 1 for it. In the background, we now go, okay, we're nested. So we've got a nesting score in the background of 1. And when we hit the second loop, we set our second for, we score 1 for it being a for loop and 1 for it being nested. So we get 2 in total. And then the conditional on the inside is now nested twice and is a conditional. So it scores 1 for being conditional, 2 for being nested twice. Then we drop out the inner loop, get another conditional, so that scores 2. And then we finish the function. And ultimately, this now scores 8 in terms of cognitive complexity, whereas our get words function is a single switch, which is very easy to understand, and scores 1 for being a conditional overall. I think, so just with these 2 examples, like cognitive complexity feels better in terms of that idea of readability and understandability of a function over psychomatic complexity as a score, I think. And so the number 2 highest rule that fails in analysis of JavaScript projects is that cognitive complexity of functions is too high. And too high has to come with a threshold of sorts. And that threshold, I guess, can seem arbitrary, but we'll get to it. In Sonar, we keep that threshold at 15 for JavaScript projects. And given that we've just seen 2 functions that score 8 and 1, I mean, the one scoring 8, relatively complex, 2 loops, 2 conditionals, but it's still only 8. 15 is our kind of threshold for cognitive complexity. And I wanted to show you a little example of that, because it turned out, in order to get confetti on my slides, I had to write a plugin to Reveal.js to throw confetti onto my slides. And then I wrote it badly. It's a fairly long and annoying thing. That I have Sonarlint installed in VS Code here, and it is telling me, it says there's an issue, it says to refactor this function to reduce its cognitive complexity from 16 to the 15 allowed. Which is nice of it to tell me that I wrote too complex a function. But what is better about it is actually it can tell me all the places that we're adding to the complexity. So I'm just going to open up show all locations for this issue. And this is actually now going to point out to me all the places I'm causing a conditional or a loop and increasing the complexity of this function. So we start with one big if around the whole thing, which is not a great start. That's a 1. And then, so now everything's looped and everything's nested inside that. So everything's scoring 1 or more for being nested. So this is a ternary scoring 2. That's a second ternary scoring 2. We've got another if scoring 2, an else if. That's just getting 1 because it's the same thing. Another ternary, which is nested twice now, it's scoring 3. There is this big sort of, a couple of times I use big options blocks. They're actually not causing me trouble. They're just static and not a problem. But we do, just have a bunch of variously nested stuff. And so with a threshold like 15, obviously it takes quite a bit, a bunch of conditionals, a bunch of nesting, a bunch of looping in order to trigger that. And what it tells me is if you get to that stage, it is a good time to look and and refactor this whole thing. If we're crossing 15 as a problem, then we can probably do something about it. But we should not just do enough. Like 15 is not the target, I think, in this particular case, which is like every function should be a complexity of 15, otherwise they're useless. What we could do is, create a function that gets me a data attribute, which is integer data attribute. So that's what we're doing here in these ternaries that I'm doing, is actually reaching into the DOM and looking at an element, which is the current slide, looking at its confetti colors, or looking at an attribute in its data set, splitting it, and then turning it into that's a string, no, that's an array. This one is, this one's getting the confetti particle count. So we get it, and then we turn it into a number, turn it into an integer, or a default integer. And so if we write the function integer data attribute or default, and we take the element, the attribute, and the default, and then just kind of return basically what we're doing here. We can get rid of this, and that'll be L. Oops. And this will be the data, that's the attribute, and then that's the default. Oops. And then we can replace particle count. We can go, integer data attribute or default with the current slide and confetti count and 200, which is my default there. Oops. And once we've done that, we're done. SonarLint, stop complaining. We've hit 15. Well done. Nailed it. We removed a single conditional from this. Now, what I like here is that this actually tells me I should be looking at this whole function in general and fixing it for everything. We have other places that we can actually apply this integer data attribute or default function, because there's more than one place I'm doing an integer lookup. And ultimately, I did rewrite it to look a bit nicer. So we have that integer data attribute or default with this array from the data attribute, a bunch of functions to do a small amount of confetti, a large amount of confetti, and a medium amount of confetti, which has that big settings block in it, but that doesn't need reading. And then ultimately, the on-slide transition end function then becomes readable on one screen in my editor, even when the font's 24 pixels, and it all makes a lot more sense. And the confetti still works, but I'll be much happier when I come back to rewrite this again sometime, or for another framework or something like that. And so 15 is not the target, but once you hit 15, it gives you a good reason to go back and really actually look at the thing again and try a proper refactor. And so that's cognitive complexity. It is turning out to be too high in a lot of our functions. I've got one more thing. I think I'm running a little out of time, but one more thing on complexity is that I understand that there is inherent complexity in many things that we do. And the idea of reducing complexity is to reduce it to the amount of complexity there is in the problem itself, and not include accidental complexity, the complexity that we kind of add into things by making things a little bit too confusing to read. So that's for our top 5. We had unused assignments, using double equals, commenting code out, the cognitive complexity of functions, and using var. Get rid of those vars, we can do it. If you are looking for some tools to help you in identifying and removing these issues over time, like I said, Sonar Cloud is SaaS-based and will scan your thing in the cloud. SonarQube you run yourself, but it does effectively the same thing. SonarLint will live inside your editor. ESLint can live inside your project and your editor and use that. It's also open source. And if you want to use, so ESLint doesn't support the cognitive complexity score, but Sonar wrote an ESLint plugin as well, which also gives you cognitive complexity within ESLint. If you're already using ESLint, check out the ESLint plugin, Sonar.js. And I have some other links. I'll share these slides. In fact, there's a QR code on the last one. But ultimately, again, I just want to encourage you to write clean code. And when I say clean as you code, that's talking about fixing things up as you find them, as you come across them. Refactoring something that is overly cognitive complex might be a little bit more work, but removing those bars, removing those commented bits of code, everything can help ultimately tidy up your code base and make it better in the future. Then refactor those complex functions, code for readability, code for yourself in the future, and you and your team will be much happier in that future when you're all reading code with no technical debt, which ironically is also what Luke is talking about in the other room there as well. So that's it. That's me. My name's Phil Nash. I'm a developer advocate at Sonar. These slides are behind that QR code. Find me online, ask questions, and I've run out of time. So thank you very much.